Hello, welcome to today's video. Sorry it took so long, I was busy doing other stuff. So, I decided to try and emulate CRT. Now by default, it is super slow because Scratch isn't exactly the strongest engine. So we're going to use turbo mode. Even then, it is still very slow. Luckily, we can zoom in. So I'm going to explain my inspirations, why I did this, and what it means. So, first thing we're going to do is zoom in. So, I was inspired to make this by how CRT televisions go row by row. Now, while real televisions do this a lot faster, here I've just kind of made a little mock-up. So, I've added a few features that are quite fun to play with. So, we can move this display. It looks a lot better at different displays, so let me just... There's a little bit of waviness because that's just kind of how my engine works. There's also one that follows the mouse. It can also flash. Now, what I'm going to do is simply press the 1 key. Now, it repeats the image because it's using two types of data, and lists in Scratch are annoying and limit at 200,000. But ignoring that fact, you can see you can take multiple types of data. This is light data. This is the full image minus this image, which gives you this image. Then you've got that with colour data. Then you've got something very similar, except this time it uses an alternative rendering method. 6 is forced one colour with a modulus. Editor Josh here. I never actually explained what a modulus is, so I'm going to explain it now. So in Python, if we have a, that is 10, x plus equals 1, but then we do a modulus of 200, no, we'll do 20, then we make it weight, it counts, and then rolls back to 0. Now on Scratch, it's basically identical. The only difference is, instead of having to do a percent symbol, the mod symbol is here. Now when this comes to colour data, it's very simple. If we, for example, change the colour, you'll see that it colours, and then when it reaches a certain point, it resets. This is what a modulus does. Hope it helped. See ya! And 7 is reverse colour mode. Now, there are also a lot of other things we can do with this. Space reevaluates. The Y key. This. Then we've got U. I. O. Z. X. C, B, and B. The next part of this video is going to get a bit technical, so yeah, let's do this. So by default, we've got this rendering script, which is what does the colours. This, if you're crazy, you see this cool wavy effect. So how does it work? Now, each button activates new render code because it renders like a CRT from up to down constantly by the hundreds of renders, or 80. So renders is how many times it's rendered. Average render time is just the average render time. Pointer is a very special value for each part in the list here, which has different colour IDs. It uses pointer to point to places. We've got X limit, which is just the rendering box to save pixels. By hard-coded Y position, it goes from one side to the other. The best way to see this is probably, see it goes across and around, across and around. Now with turbo mode, it's basically instantaneous, but not always this quick. Now there's a few weird things about this code and the way that this is sorted. For example, if I go into 4 pixel mode, re-render, press the W key to make it follow mouse, and then switch to 2 pixel mode, you'll see it's at the top of the screen, and as well as 1 pixel mode if we give it time to render. Now this is most likely just because it's always like in multiples of 2, so I'm guessing it's just because of how this is set up. But if you've got any other thoughts, make sure to put them in the comments. Nevertheless, this is the cool thing I made. I plan to do more with this, but for now it's kind of just how it is. Alright, see ya!